Good afternoon. Welcome once again to yet another interesting Jamb episode of mathematics. For this Jamb journey, we would be looking at a very interesting and important concept of mathematics. This concept is the concept of variations. In some texts, you would also see it as proportions. Whatever name you decide to call it is fine. However, what remains very important and paramount is the fact that you must understand that it's a relationship between one concept or one term or one variable with another concept, term, or variable. And that's a very key factor. To that end, it means that when we study the concept of variations, we consider the relationship between one variable with another variable. Whether an increase in the first variable causes an increase in the second variable, or an increase in the first variable causes a decrease in the second variable, or those two variables have nothing in common, or those two variables have everything in common. We'll be looking at all these scenarios one by one. For this course, or for this topic, we will be looking at the concept of direct variation. We will be looking at the concept of indirect variation. We will be looking at the concept of mixed variation. And we will then be looking at the concept of partial variation. These four concepts have very important and essential roles they play, not just in mathematics, but also in their use in real life. This is because for each term or for each proportion, it causes a representation in how those values are translated. Let's take a real-life example. You have a family with 4 children. Because of the fact that there are 4 children in that family, it reduces the amount of workload that will exist for each child. This is because the workload can now be split along these children, and each of them can take a portion of the workload. Now imagine if that same family had just one child. At the end of the day, that one child would have to be the one to bear the entire workload. Or the family can decide to take a house help that will now be the one bearing all the workload. At the end of the day, you would find out that having more, which means much more regulated workloads, which also means that there is much more tendencies to reduce the workload across board. When you compare that to having just one person shoulder all the burden, you'll find out that dividing is better than having everything on just one person. This is one of the most important real-life concepts that variations serve to cover. Now, let's now look at this concept: direct variation, indirect variation, mixed variation, partial variation. Let's look at them one after the other. We will look at them, we will solve questions on them, and we will now see the relationships, we will now look at the relationships, if any, that exist within this concept. So let's begin. We'll start first and foremost with the direct variation, or what you can also call the direct proportion. Anyone is fine. Now for the direct variation, in plain English, you are simply saying an increase in one value causes an increase in another value. Now, of course, let's digress a little bit. If you are a little bit concerned about how exactly is this concept important, it not only relates to mathematics, we have also shown that it relates in real life with our little analogy, But more importantly, it's also very, very important in other fields of science. For instance, if you consider the field of physics and you look at concepts under Charles' law, Boyle's law, those concepts, of course, it's in physics, it's also in chemistry as well. You'll find out that Boyle's law, Charles' law, ideal gas law, these concepts use the concept of variations or proportions. The Boyle's law talks about the relationship between one particular quantity with another quantity. The Charles' law also talks about one quantity with another one. When you say P1 V1 is equal to P2 V2, you are essentially discussing the possibility of a relationship between the pressure and the volume. When you say V1 over T1 is equal to V2 over T2, you are also essentially discussing the possibility of the relationship between the volume and the temperature. Once you are done discussing these different types of variation, you will now identify it yourself which of these kinds of variations are we talking about. And of course, it's not just in Boyle's law and Charles' law. You have the concept of resistance in series, resistance in parallel, and in those concepts, you need the study of variations as well. So let's begin. We will start first and foremost, as we have mentioned, with direct variation. Now, for direct variation, we are saying one major thing. It's not different. We are saying a variable P, let's decide to call it P, is directly proportional, that's the key word, directly proportional to another variable Q, right? A variable P is directly proportional to another variable Q. That is basically what direct variation is saying. Now, how do you write this? Now, mathematically, you are saying P is directly proportional to Q. This is the mathematical notation, where the alpha is what we refer to as the symbol of variation, right? P alpha Q, which means P is directly proportional to Q. Now you can see this concept, this wording in different forms. Well, whereby we can say P is directly proportional to Q, we can also say that P varies directly to Q. This is yet another way in which we can discuss this. P varies directly to Q. Similarly, we can talk about this concept and just maintain that whether you see it as varies directly, or you see it as directly proportional, or you see it as P is proportional to Q, any of these wordings you decide to see is talking about direct variation. Now, what exactly is direct variation? Direct variation is saying that whenever there's an increase on P, that is whenever there's an increase on the first variable P, there is going to be a corresponding increase on the second variable Q, which means an increase in P causes a corresponding increase in Q. Similarly, a decrease in the value of P will cause a corresponding decrease in the value of Q. This is very, very important. So, if we take a real life analogy, for instance, you'll find out that the amount of, let's say you have a construction company, the amount of work you can get done in that construction company per day is directly proportional to how much staff you have. So if, for instance, you can get, let's say you are completing a building and your original perception was like, okay, you had 10 workers and these 10 workers would complete the foundation of the building in a day. What it means is that if your workforce increases proportionally to 100, then it's expected that you will not be completing just the foundation in one day any longer. You will be taking it probably to the lintel or to the window level. That is essentially what it means. Similarly, let's say you have a snack business, let's say pop-off, for instance, or donuts. And with 3 workers, your company is able to make 100 donuts in a day. If you increase your staff to 10 workers, definitely the number of donuts you can make will also increase. This is what we call a direct variation, right? So an increase in one parameter is causing a corresponding increase in the second parameter. This is very, very important, and it's something you should keep in mind. So I'll write it as a note. Increase in one parameter, or let's use P. Increase in P causes an increase in Q. So always keep this in mind as far as direct variation is concerned. So let's quickly look at an example on variations, on direct variation, before we now move further to take yet another type of variation, so that we'll see exactly how it works and, of course, how we solve questions relating to it. So we'll pick one to explain the concept, and then we will now pick more examples, more general examples, when we are done picking all the concepts. So let's start with one. So, example. So let's take this as our example. It says if x varies directly as the square root of n, and x is equal to 9 when n is equal to 9. That means whenever the value of n is 9, the value of x is 9. Now we have to find the value of x when n is equal to 16. This is the basic question. Now let's pick out the key point. The key point is the fact that it is varying directly. Varies directly is telling you that it's a direct variation or a direct proportion, anyone you decide to call it. Now, if it's a direct proportion, that knowledge is enough to guide you on how your answer is supposed to be. Remember, for direct variation, if there is an increase in one quantity, there has to be the increase in the other quantity. Similarly, if there is a decrease in one quantity, there has to be a decrease in the other quantity. That is unchangeable. So now we can compare. We have never started solving. Let's compare. If x is 9 and n is 9, for the new value of x, we can look at the value of n to give us an int. N is now 16 over 9. Now, n was originally 9. The new n is 16 over 9. Obviously, n has experienced a decrease in value. 16 over 9 is obviously roughly like 1.7 something or 1.8 something. So obviously, n has decreased from 9 to 16 over 9. So it means that you are expecting that whatever value of x you get, it has to be smaller than the previous value of x, which was 9. because of the decrease in the value of n, there has to be a corresponding decrease in the value of x. That is the very first way in which you give yourself the correct guidance on how the question is supposed to turn out. This is very, very important. So now that we know that, okay, we expect x to be a smaller value compared to the previous x, let's now put it to practice. The very first thing is, let's piece out this definition. We are saying x varies directly as the square root of 9, right? So it means that x varies directly as the square root of n. This means that x alpha square root of n, right? Now, this is very, very important. This is the very first translation, right? By definition, whenever we have a direct variation, the first quantity or the first variable is to the left-hand side, and then the second variable is to the right-hand side. So we have x alpha square root of n, which is the same thing as saying x varies directly as the square root of n. Now the question that we have to ask ourselves is, all right, now we have written it at this form. How then do we proceed to solve this question? It therefore follows that we would have to convert the symbol of variation into a mathematical equation symbol. Now, how do you do that? Very, very simple. If you have that P alpha Q, that means P is directly proportional to Q, whenever you decide to replace this symbol of variation, it is replaced with an equal to sign and a constant of variation. So this symbol is replaced with an equal to and a constant of variation. How? This is what I'm saying. P will now be equal to the constant of variation multiplied by whatever was in the right-hand side. Right? P will now be equal to the constant multiplied by anything on the right-hand side. So this dot here is just the multiplication symbol. So I'm saying P is equal to KQ, right? Where this K is the constant of variation. So now I can use this to solve my problem altogether. Now, as a digression, this is something that if you look closely to your Boyle's law, you should already start finding some similarities between them on how they operate. That aside. Now, we have converted the symbol of variation into the constant of variation. How then do we proceed to solve? There are two distinct steps that you need to do. Step one is determine the constant of variation. This is the very first thing you have to do. The moment you are able to convert into this form, your first priority is to determine the constant of variation. Once you are done, you can now move on to the next and final step. So first and foremost, I convert x alpha square root of n to become x is equal to k times square root of n, of course, which is the same thing as x is equal to k square root of n. This is very, very important. Now, I need to determine the constant of variation. So what do? I make the constant of variation subject of the formula. Now, what does it mean to say subject of the formula? Subject of the formula is saying isolate that variable on one side of the equation. For instance, at this point, x is the subject of the formula because x is isolated on the left-hand side. So if I decide to make k subject of the formula, it means I'm saying isolate k to one of the sides of the equation. So how do I do that? K is attached to square root of n, so I will divide that equation by the square root of n. So if I divide by the square root of n, this would imply that x will be divided by square root of n, and this will be k square root of n divided by square root of n. Pretty much interesting. And then at the end of the day, I can now have that k is equal to x divided by square root of n. I hope this is clear. All I've just done is isolate k to one side of the equation. Obviously, the square root of n will cancel the square root of n, and k will be left alone on this side. Now that we have the constant of variation in the subject of the formula, we need to determine what the value is, right? So we proceed. We have used this part of the statement, right? We have used it, we have interpreted it mathematically. Let's now go to the second part of the statement. And x is equal to 9 when n is equal to 9. That's the next part of the statement. We use this part of the statement to determine the constant of variation. How do we do that? So, when n is equal to 9, x is equal to 9, right? By definition. And n is equal to 9 when x is equal to 9 when n is equal to 9. So we are telling us that these are the values of n and x at inception. Now, we will now use these values into the subject of the formula we have derived for k, and we will use that to find the value of k. How? This will now imply that k will be equal to x, which is 9, divided by square root of n, which is 9, so we have square root of 9. Right? And this would give us 9 over 3. So this means that k is equal to 3. So we have ourselves our constant of variation, which is 3. So now that we have gotten our constant of variation, the next thing that is now essential for us to do is step 2, which is obviously the final step. Step 2 would now be determine the value of x, right? And that's the final part of the statement. Find the value of x when n is equal to 16 over 9. So this first step is general for every question. You have to determine the constant of variation first. And then the second step is to determine the value as requested in the question. That is very, very important. Keep that in mind. So in this case, what do? I determine the value of x. So I have that n is equal to 16 over 9. That is the new value of n that I've been given. I am already done with this statement. I've used this statement to determine k. Now I am on this statement. I am looking for x, right? I have been given that n is now 16 over 9, right? I have also determined that the constant of variation is 3. Now, regardless of any changes that happen between x and n, the constant of variation will always remain the same within that question, right? So, the moment I determine that the constant of variation is 3, that means for this second step too, I will be using that constant of variation, which is also 3. Remember, that's why the name is constant, right? Which means that value of k does not change within that variation. So, k is also 3, and then I am looking for x, right? So, what do I need? I need the formula for x. Obviously, x is equal to k square root of n. I can see that here, so I just recall it. X is equal to k square root of n. So this means that x will now be equal to k, which is 3, times the square root of n, and n is 16 over 9, so this will be square root of 16 divided by 9. And do not forget, square root of 16 is 4, square root of 9 is 3. So this means that x will now be equal to 3 multiplied by 4 over 3. 3 cancels. That will mean that x is exactly equal to 4. Simple, straightforward, and efficient. So, what have we done? We have determined that value of x as required, and the value is equal to 4. The process again. First off, we translate the variation statement. X varying directly as square root of n means this. From here, we determine the constant of variation by turning this symbol of notation of variation into the constant of notation of variation. Now we determine the constant of variation by making the subject of the formula and then imputing the original values. Thereafter, we now determine the value, the unknown value from the question by putting in the new value of its opposite variable and the constant of variation we have determined. So therefore, we are able to find that x is equal to 4. Now, this aligns with the very first assumption we made, which is the fact that because n has experienced a decrease in value, x must also represent a decrease in value. Because if you compare, the original value of x is 9 and the new value of x is 4. So the value of x has in fact decreased from 9 to 4, just like the value of n decreased from 9 to 16 over 9. So always keep that in mind. Whenever you are doing direct variation, an increase in one value will cause an increase in the second value. Similarly, a decrease in one value will cause a decrease in the second value. I hope this is very, very clear. Now we have given ourselves a look into the concept of direct variation. The next step will now be to take this a step further and look at the concept of indirect variation. So if direct variation is said increase in one variable is causing increase in the second variable, what is the indirect variation talking about? So let's take the indirect variation. Now,